So the zero product rule here, let me write it this way. That's when you have two things multiplied together. Here equals 0. So here I have a product. It equals 0. We call this the zero product rule. So if I ever have a product of two numbers equal to 0, then what am I guaranteed to know about the numbers? What do you think? What's that?
One of them is 0.
One of them is 0, or what? Or both 0. Yeah. This is the zero product rule. Now, this rule is so important in mathematics that it's used from here on in every math course that you'll ever see. This thing called the zero product rule. And so I actually draw this T here just to separate the terms from a triangle and a square. What this means is one of them is 0 or they're both 0. So that means, for example, let's note so we can give you guys some ideas about this. If I have, for example, 2 times 0 and it equals 0, right? If I have this, then what did I know? Wasn't one of the numbers 0? And the answer is yes. Okay? So one of the numbers was 0. So we don't have to write it this way, but here's the point. Notice this. If I had 0 times -3, isn't that also 0? So here, again, one of the numbers was 0. And then what we can say is, isn't 0 times 0, 0? And in this case, both of the numbers were 0. So this is really an illustration, let's get this out of the way, of the zero product rule. Okay? But you might say the following: what if you're given something that looks like this, for example? Like example 1. They're going to tell us to solve for x, right? So we're going to have to solve these equations for x. And you have x plus 4 times x plus 2 is the value 0. Okay? So here's, again, your first equation. It is quadratic, by the way. Okay? You're going to see why that's quadratic a little later. It's quadratic because, well, let's tell you guys now why is it quadratic. If you use FOIL but don't use FOIL, don't we get x squared, plus 4x plus 2x plus 8, and that is 0, and you get x squared, plus 6x plus 8 is 0. So notice again, the highest power here is 2. It's a quadratic. Okay, it's a quadratic equation. Don't use FOIL. We're here trying to solve this quadratic, and you know that because they tell you, they say, solve. And you're solving for the variable x, and what do you guys notice? I got a product here between the two terms because there's nothing there. It's blank. So between those parentheses, we really have a product here. Okay, bless you. And that product equals what? 0. So we're using, again, the what? The zero product rule. Okay, now what the zero product rule says to us is this. Don't I have a triangle here? And don't I have a rectangle? If I have those two things multiplied together and it equals 0, then what I can say is the following. Right? Then either the term x plus 4 equals 0, or the term x plus 2 equals 0, or really both. Okay? This is the zero product rule, but you're not done, right? You have to solve here now for x. I'm going to solve the left side for x. I'm going to solve this other for x. So I actually have two equations, one on the left, or this first equation, second equation. So how do you guys solve these for x? Right? Don't you subtract 4 from both sides here? And you end up with what? X is -4. That's one solution. And then here, we subtract 2 from both sides. And what do we get for x? X is going to be now negative 2. So a solution set would look like this, right? They're going to put these in set notation. This is known as a solution set. So either way you express the answer to me would be fine. You can say, for example, x is negative 4 or x is negative 2. Or you could write it as a list. This is the list format known as a set format. Okay, right here is the list format, aka set notation. Okay, so this is an illustration of how you would use this zero product rule. Okay, does anybody have any questions on this first one here, how to use the zero product rule? No? Let's look at equation 2. Our example, let's look at example 3 here. 3, we have x plus 5 times x plus 1 is 0. Okay, let me remind you, you have a product here, and you have what? 0. So you're going to use the zero product rule. Zero product rule says if I ever have a product of terms and they equal 0, right? Like in this case, triangle and what? Square. That means x plus 5 is 0 because that's in my triangle. Or x plus 1 is 0 because that's in the rectangle. And then, of course, you do what? You solve for x. Subtract 5, subtract 5. Subtract 1, subtract 1. What do you guys get? X equals negative 5. Or x equals negative 1. And you're done. That's number 3. Okay, you guys okay with that? Number 5. X plus 1 times x minus 2 is 0. You have a product here, and it equals 0. So what do you guys do? You set x plus 1 equal to 0. You set x minus 2 equal to 0. And what happens now? Solve for what? You're going to solve for x. Okay. Subtract 1 from both sides. Here, add 2, right? And what do you guys get when you solve this? This is x equals negative 1, or x equals positive 2. Negative 1 and what? Positive 2. You are done. Okay, anybody have any questions on this here? No, you sure? Bless you. What about number 7? Let's see example 7. We have x minus 6 times x minus 2. This equals 0. Notice product equals 0. We're going to use the zero product rule. So I get x minus 6 equals 0. I get x minus 2 is 0, right? Or this. Solve for x. Add my 6 to both sides. Add my 2, right? Isn't that how we solve this for x? We get x equals 6, x equals positive 2. Right? These are my solutions. Solution set notation, 6, comma, 2. That's as a list. So you're done. Okay, anybody have any questions on this example? No, you sure? All right. All right, let's see. Number 9, we have what? x plus 6 times x plus 4, and I think that equals 15. Okay, you guys okay with that? Now let's double check. We have a product, but what's the problem here? Yes, see this? This is not what? 0. So in order to use the zero product rule, you always have to have that equal what? 0. It has to be 0. If it's not 0, you can't use the zero product rule. Now, I want to point out to you guys something here. This problem requires us to simplify. And how we simplify is the following. We are going to use FOIL here now. And I'll show you why we do that. So when I use FOIL here, I get the following, right? I get, well, let's get this FOIL out. X and 6, X and 4. Let's get our FOIL box. We get x squared and 4x, 6x, and 24. So notice when we do our FOIL, the diagonal terms are like, and we get x squared plus, what's 6x plus 4x? That's 10x plus 24 will equal the 15. Okay? Now remember, like you guys said, the 15 over here is not 0. So how do you make it 0? Good. Subtract 15 from both sides. Be fair. And you get x squared plus 10x. What's 24 minus 15? That's plus 9, and that equals 0. It's number 9. Okay, now you look at this and you say to me, okay, we have 0 on this side, and that's what we need, but we don't have a product now. So I'm going to write this down here. What's the product going to be if I have to use the zero product rule? Okay, so does anybody know, how do we get a product out of a sum of terms? How do we think we get that? We have to what? We factor. Okay, remember, factoring is writing a sum of difference as a product. So you actually want, you know, this product here, you want it to equal 0. So the question now is going to be, how do I get that product? The only way you could get the product now is to what? To factor. So how do you factor this trinomial of x squared plus 10x plus 9? Does anybody know a recipe that you guys use for this? Was it the chicken soup? It was chicken soup or beef stew? I think it's what? Chicken soup. Is that right? This is of the form x squared plus bx plus c. So as you guys can see, we're going to factor this using our factoring technique. And yeah, it was the x squared plus bx plus c. Informally, we call it here, you know, chicken soup, because it's just a recipe. All right, you guys remember, did you do all your homework on that? Okay, good. Then what did you guys get when you factor this? Don't you get what? 9. X, what is it? 9 and 1, and they're both what? Positive? Okay, good. And guess what now we can use? Use the zero product rule. Now the zero product rule says the following. If I ever have a product, I got the product by factoring, and it equals 0, well, that means the first term is 0, or the second term is 0. Okay. What's left to do now? Solve for what? Subtract 9, right? Subtract 1, and we end up with x is negative 9, or we end up with x is negative 1. Negative 9, comma, negative 1. Okay, so the secret here to solve these kind of equations is to factor and use the zero product rule, and you got your solutions to these quadratics. Okay, and that was number 9, or example 9. Let's see 11. If we look at 11 now, we get x plus 2 times x minus 7 for number 11. That's negative 18. Okay, so again, in this problem, again, remember, this is not what? It's not the number 0. Foil. So we need a FOIL box. X and 2, x and negative 7. X squared minus 7x, 2x, minus 14. My diagonals we can combine, and we get x squared minus 5x minus 14, and then that equals negative 18. Right? We didn't do anything with this number at all. But we are now. What we're going to do now here is we're going to add 18 to both sides. I get x squared minus 5x plus 4 equals a 0. What do you guys use now? You're going to factor. Okay, now what recipe? Chicken soup or beef stew? Chicken soup. Okay, good. What do you guys get? X, X. What are the numbers here? Negative 4, negative 1. Good. Look at that. That's what it is. Okay, so I'm going to write this in our notes here. Use the zero product rule because you have a product now and it does equal 0. Okay, so zero product rule says this. Set both of those terms equal to 0. And then you're going to solve for x. Okay? So, add 4 to both sides. Add 1 to both sides. X is 4. Or x is what? 1. Here's a solution set. 4, 1. You are done. Okay, we solved this particular quadratic. Let's go back up here to show you. A quadratic equation, highest power is 2, and that equals 0. So these are our solutions, 4 and 1. And this is problem number, or example number 11, same thing. Let's now look at 13 and see what they gave us. They have x squared minus 11x plus 30 is 0. Okay? Now the good news is we have what? We have 0 already. So that's good. That's different than what we had before. But what's the problem though? You don't have a product. You have a sum and difference. So how do you get a product? Yep, we're going to factor. Now, x squared plus bx plus c is the recipe we have to remember, right? This is chicken soup again. So I'm glad you guys worked on all those problems. As you guys can see, they're back because we have to factor. So x and x, what are the numbers? What are they? Negative 5, negative 6. Thank you. Look at that. Negative 5 and negative 6. What do we say? Put it in red. Use the what? The zero product rule. Zero product rule says, since now I have a product and it equals 0, we're going to set both terms, x minus 5 equal to 0, or x minus 6 equal to 0. Right? What do you do now? Add your 5, add your 6. X is 5, or x is what? 6. So your solution set's going to be in back of the book. You see 5, 6. Right? And here's your solution. And you're done. Okay, you guys okay with this one? Let's hope they get harder. Right? Let's hope they get harder. Let's see. 15, example 15. Oh, let's see. X squared minus 12x plus 27 is 0. So again, I have my 0, but I don't have a product. So I guess I have to what? I'm going to have to factor. What's the recipe? Chicken what? Chicken soup. Is that true? Chicken soup recipe. Here we go. X and X. Your product is what? 27, and your sum is negative 12. So what are the numbers? Are they negative or positive? They're both negative. Good. Good. Now we have a product and 0. Use your 0 product rule. X minus 9 is 0, or x minus 3 is 0. Okay? Add your what? Add the 9. Add the 3. X is positive 9, or x is what? Positive 3. What's the solution set? 9 and what? 3. Good job. Okay, you guys okay with this one? All right, let's see. 17. X squared minus 2x minus 24 equals 0 here. All right, let's see. Okay. All right, as you guys can see, we got 0, but we got no product. So we factor. Is that chicken soup? Sure is. What are the numbers?
6 and 4.
Okay. What are the signs?
Negative 6.
-6. Good. Good. Okay. Now we have a product and 0. 0 product rule. Okay. X minus 6 is 0, or x plus 4 is 0. Add 6. Subtract 4. X is positive 6, or x is negative 4. So here, solutions are 6, negative 4. And that's your 17. $19. X squared minus 4x plus 4. This is 0. You got 0 here, right? But it's not a product, so we're going to have to factor. And when I factor, okay, again, chicken soup. What are the numbers? -2, yeah. -2 and -2. Good. Use 0 product rule. X minus 2 is 0. X minus 2 is 0. Add your 2 to both sides. And you get x going to be positive 2 or x going to be positive 2. Now, notice here, as a solution set, if you're looking back at the book, you know what you're going to see? A single number. Does anybody know why?
Both X?
Huh? What's that?
They're both X?
Well, yes, they are both x, but more importantly, what's the value of both?
Same.
The same value, right? So you have here 2 is the same as what? 2. This is a list, okay? It's a list. So if you know you have to buy orange juice, how many times do you put it on your grocery list? Only once, right? If you know you have to buy mom a Christmas present, how many times do you put mom in that Christmas list?
A lot.
Once?
So you don't
Oh, a lot. Mom. Yeah. Well, here you only list mom once because if she's there once, you won't forget. It's already there. It's kind of like even if you go say, okay, I'm going to buy bacon at the grocery store, and you go, I love bacon. Are you going to put bacon 10 times down? Maybe. But in set notation, we only put bacon down what? Once. You guys like bacon? Just curious. What's the weirdest bacon thing you've eaten?
Vegan bacon.
Vegan bacon? That's weird. A bacon donut? They're good? Huh. Really? Bacon donuts are good.
It's maple bacon.
Maple bacon?
It's like a maple glazed donut with bacon on it.
Oh, really? Is it good?
I don't know.
Bacon ice cream?
You eat churro. You can't mix milk with oil.
I don't know. I don't know. People do anything. That's the thing. That's it. If you can find something new, different, crazy, somebody will make it.
You know there is a burger flavored beef jerky now?
Burger flavored jerky?
Yeah.
Burger flavored?
Burger.
That's weird. Like mustard and ketchup and onion. Oh my god. That's funny. Get some bacon face cream. Never mind. I think they have it.
We're just gonna eat pellets.
What do you guys think here?
Grind everything up and put it in one pellet.
Yeah.
Save a lot of money.
Yeah.
Equal to 0.
Yeah, we got a problem here. We got to set this equal to 0 here. Okay. You don't have 0. You go, oh my gosh, this is not 0. Well, that's okay. Just subtract that number from both sides, and you get x squared minus x minus 12. Now that equals 0. What do you guys do with this again? What do you guys do? You factor. Okay, now again, it's the chicken soup recipe. So x and x. What are my numbers now? Good. 4 and 3. Which one's negative? Good. All right. And now we're going to say, we're going to use that 0 product rule. This is kind of our reward for all the factoring homework, actually, is solving quadratics. So we get x minus 4 is 0. X plus 3 is 0. Right? So let's solve these equations. You're going to add 4 to both sides to solve them. Subtract 3 from both sides to solve them. And you get x equals 4 or x equals negative 3. These are my solutions here. So let's list them. 4 and negative 3. You are what? You're done. Okay, you guys okay with that? Okay, let's take a look. let's try 23. X squared equals 6x minus 9. So what are you going to do? Again, this portion is not 0. Okay, we know that. So how do we make it 0?
With the X.
Yeah, you can translate the terms, or subtract 6x from both sides, right? Or translate the 9, or add 9 to both sides. Now, what you have on the left side will be x squared minus 6x plus 9. And on the right side, now you have 0. So I can look at it that way. I can subtract and add the terms so I get 0. Or you translate whatever you like. Notice again, you have 0, but you don't have a product. Use your recipe. Use your chicken soup recipe. And then you see we get what? Minus 3, minus 3. I now have a product that's equal to 0. I now use the 0 product rule. And the 0 product rule is going to say this. X minus 3 is 0, or x minus 3 is 0. Okay. Add 3 to both sides, and you get x is 3, or x is 3. Okay, you're looking back at the book. Again, only one number on the list because they're going to be the same number.
Would it be wrong if you put both threes?
No, it wouldn't really be wrong. It just won't be efficient. You know, it's like that idea really of putting orange juice twice on the list. It's really that same thing. You know, so it's not needed. You know, or if you said I listed my mom twice in the, you know, it's not needed. I wouldn't mark it wrong, but you won't see that like in back of the book for that. Okay, so this is number 25. Or was that or was that already 25? Let me see. Maybe we made a mistake here. 23. X squared. Oh, it's okay. 25 here. X squared plus 10x is negative 25. Actually, just to clarify, just to be clear, this was actually 25, and this is not. This is actually 23. So I want to be clear with that. Okay, not such a big deal, but okay. We notice this is not 0, but that's okay. We can make it 0 by doing what? You add your 25 to both sides, and you end up with x squared plus 10x plus 25. Is that value 0? Once again, we got 0, but no product. Going to factor. X, chicken soup, isn't that plus 5? Plus 5, so I got my 0, I got my product, and what do I use? The 0 product what? Rule. Here we go. X plus 5 is 0. X plus 5 is 0. So what do you guys do? Subtract 5 from both sides, and you end up with x is negative 5. Or x is negative 5. And you are what? Done. You only see the negative 5 here listed twice. Or once, sorry. Once. Okay, that brings us to number what? 27. So remember we said, I hope they become a little more difficult. 27. 2x squared plus 11x plus 15. And that equals 0. Okay, now the good news is we got what? 0. And you notice again, you don't have a product, so you can't use that 0 product rule. So you're going to have to factor. But what are you looking at? Beef stew. Absolutely. A different factoring strategy. Okay? So this is, so you guys pay attention to this. That number here, the A value, is 2. If the A value were 1, well, then that would be the chicken soup. But here A is 2, a different factoring strategy. So remember yesterday, or remember when we did this factoring strategy, let's recall how to do this. Don't we need a product to be, this was A, B, and C. My product is 2 times 15, which is 30. And my sum was 11. I needed 2 numbers who multiplied together was 30, but when added was 11. What were the numbers? 5 and 6. That works, right? And so we said, okay, we're going to get 2x squared plus 5x plus 6x plus 15. That equals 0. And then we factor by what? Grouping here. And it looks like an x comes out, and we just have a 2x plus 5. And here's 6 and 15. A 3 comes out, and we get 2x plus 5 again. Well, factor the common term of 2x plus 5. We got an x plus 3, and this is 0. In other words, this was the what we call the beef stew recipe, right? Whenever that value here we have is A and it's not 1. So now we'll say to you, use your 0 product rule. And if I use that 0 product rule again, two x plus 5 equals 0. X plus 3 equals 0. Here's what we're going to do. Subtract 5. Okay. And you get 2x is negative 5. So we're solving for x. Divide both sides by 2. And now we get the value that x is negative 5 halves. Here's my answer. Subtract your 3 now. And you end up with x is negative 3. So if you look in back of the book as a solution set, negative 5 halves, comma, negative 3, these are my answers. This is a solution to this quadratic equation here. And we're done. So as you guys notice, you have to remember the chicken soup recipe, or x squared plus bx plus c, factoring. Or the beef stew, factor ax squared plus bx plus c. And what do you think might happen eventually? Probably also factor what? Special factors. Is that right? Yeah.
Can you put negative 2.5?
You could, but I would prefer the fraction as long as it's reduced. In the back of the book, you'll see a fraction answer. All right, you guys okay with that? See, this is the reward for factoring. All those hours that you factored, you now get to use. So I get 3x squared plus 13x plus 4 is 0. So notice again, you have 0, but you don't have, you don't have here a product, so you can't use a 0 product. You can get a product if you factor. And again, you say, but that first term is not 1. That first term is 3. So you're going to have to use the recipe that we just used. Now, there's another thing we talked about yesterday, right? You can do the trial and error recipe, or the trial and error approach, sorry. This is the one that we talked a little bit about yesterday. Some of you guys probably already know that. So if I look at factors of 3x squared, I have a 3x factor and an x. I now need factors of 4. right? So I looked at these first factors. I need a factor of 4 now. What are factors of 4? 1 and 4 and what? 2 and 2. Is that true? So I'm going to use either of those pairs, but they both have to have an O and I term that adds up to what? That 13x, or 13 really. So I'm going to look for the combination that works. So what do you guys think that works? You can say 4 and 1. I'm going to say, well, 4x here, 4 times x, and 3x is actually 7x. Is that true? And that's not 13, so darn, that's not going to work. Let's try it again. Trial and error. 2 and 2. Well, 2x and what? 6x. What does that give me? That gives me 8x. Is that true? I got to have 13. That's not it. Okay. 1 and 4. Let's try that. That's 1x. What's this? 12x. Is 1x and 12x going to give you 13x? Yes, it is. These are my pairs by trial and what? Trial and error. So it's up to you. You know, you can start to do some trial and error if you like, or go back to this recipe that we just did. There's no, there's no shame in doing this recipe again all over. So either way, you can factor. Go ahead and do it. Use your zero product rule. All right. We get 3x plus 1 is 0. X plus 4 is 0. Solve your equations. Subtract 1 here, subtract 4 here from both sides, right? We'll get 3x is negative 1. Here we get x is negative 4. Here's one solution. Divide both sides by your 3, and what do you get for x? I think we get negative 1/3. Take a look. Solutions. Negative 1/3 and negative 4. Question? Yeah.
We factor by grouping here, right?
Be careful here. No. Not by grouping. Well, it depends. If you're going to use the recipe that we discussed, then the answer is yes. Right here, okay, is 4 terms, and yes, you factor by grouping. So it's part of the recipe for factoring out, for using this actual beef stew recipe. It's one of the last steps, factor by grouping. So the answer is yes if you factor it this way. But if you factor it by trial and error, there is no factor by grouping. Trial and error is not factored by grouping. So it depends. If you strictly use the beef stew recipe, yes, one of the steps will involve factor by grouping.
Yeah, that's what I did.
And that's okay. Mm-hmm. Yep. And you should get the same answer. Mm-hmm. Yeah. And that's how, you can really learn factoring really well, and you start to get better at it. And then you transition, you'll transition to trial and error. So here's number 30. Let's try 31 now. 4x squared plus 21x is what? Negative 5. Let's double check if that's 31. Okay. And as you guys can notice again, this is what? That's not 0. Add 5 to both sides, and we'll get it to be 0 now. So you get 4x squared plus 21x plus 5 equals 0. Okay, and then here we're going to say factor. And what kind of recipe is this? Ax squared plus bx plus c. So again, if you want to go back to that, we can. We can say product is what? 20. Sum is what? 21. What's the pair? 20 and 1. Okay. So the next step would be 4x squared plus 20x plus 1x plus 5, and that equals 0. Factor by grouping. For x plus 5, 1, x plus 5, common term. So we get x plus 5 times 4x plus 1, and then that's 0. Use the zero product what? Zero product rule. So zero product rule now says x plus 5 is 0, for x plus 1 is 0. Subtract 5, subtract 1. X is negative 5, or 4x is negative 1. We're solving these equations. These are linear, right? What do you get for x now? Is that negative 1/4? Yep, negative 1/4. And as a solution set, again, negative 5 comma, negative 1/4. You're done. Okay, so we're going to solve these quadratic equations, like we've been doing. So what do you guys notice about this here? Okay, we got 0, but what's the problem? We don't have a product. So we don't have that 0 product. We're going to have to do what? What do you guys do with this? We're going to have to factor. And what do you notice about what you're looking at? What is this called? Did you guys ever factor things that look like that? Right? You're going to use this is a special factor formula, right? This is known as the difference, again, of your perfect squares. So how do you factor a difference of perfect squares in general? Right? Isn't this going to be what? A plus B? A minus B? Okay, your difference of perfect square formula. So you're going to have to identify here, again, the bases. This is x. So let's try to find the basis. Right? 4 squared, how do we write 4 squared? Or 16 is, written as 4 squared. So my base here is 4. My base is x. So when we factor this, we get what? This is going to be what? X, X, 4, and 4. And what are my signs? Plus and minus. Okay? They have to be plus and minus here. So notice I have a product and I have 0. So I guess I can use again what we call the 0 product rule. So we talked about this the other day. 0 product rule. And what do? Right, I get to set both of my terms. What are the terms? First term is x plus 4. I get to set that x plus 4 equal to 0. The second term is x minus 4. So I set my x minus 4 equal to 0. Is that right? What do you guys do now? You're going to solve for x? So how do you guys solve for x? Well, you can translate. That's right. We can translate that. Move it to the other side. Okay. We can translate that too. Move it to the other side. But translation is shorthand for, adding or subtracting the same value to both sides. So you're going to get x going to be here, -4. X is +4. These are my two solutions. As a solution set, you sometimes see this as -4, 4. Okay? So going back to summarize, what you have to do here is that you're going to factor. It's like we got rid of it. You're going to factor the difference of perfect squares. And then use your 0 product rule, and you're done. So we've been factoring by chicken soup, by beef stew, and now we get to use our nice special factor formula. Okay? You guys okay with this one, number 37? Right, so here's 37. Let's see if we can do 39. So I get 39 to be x squared minus 4 is 0. Again, this is 0, but I don't have a product. I have a difference here. So I'm going to have to factor. And you say, well, what am I looking at? I'm looking at two terms. Now, this again is a difference of two perfect what? Squares. I know 4 is a perfect square because I can write my 4 as 2 squared. So my base here is 2. Now by the factoring formula, difference of perfect squares, what do I write down? You guys know what I write down? What is this? X plus what? 2, x minus 2. Okay, you write down your two bases, but make sure again you have plus and what? Minus. Now you can use a 0 product rule because you got a product. You got 0. So I don't know if you guys, like me writing down 0 product rule. Maybe you do, maybe you don't. But the 0 product rule Break out my t. X plus 2 is 0. X minus 2 is 0. All right, what do you guys do now? Subtract 2 from both sides here. Add your 2 from both sides. What do you guys get for x? X is negative 2, and x is what? Positive 2. Solution set answer right here. Okay, you guys okay with this one? Anybody have a question on 39? All right, pretty simple. Special factors here. 41, you get 4x squared minus 9 is 0. Okay, so what happens now here? Right, we got the 0 here, but we don't have a product, so we're going to have to factor. Okay, what do you guys notice? Is this a difference? It is, but it's a difference of what? Is that a difference of perfect squares? Well, we got to know, is 4x squared a perfect square? It sure is. Okay. Now, what was squared to get 4x squared? We have 2x to the second power. Is 9 a perfect square? Sure was. What was squared? 3. And you have the difference. So yes, there's a difference of perfect squares. So let's factor this. Again, go back. My base is 2x. So I'm going to write my 2x and my 2x. My base is 3. I'm going to write my 3 and 3. What are the signs? Plus and minus. Okay? I'll write it down again. The zero product what? Rule. Remember, I got a product here. Here's my first term. Okay. And my second term. So, what's the first term? Isn't that 2x plus 3? And that equals 0. The next term, 2x minus 3. So, I'm going to use these terms here. First term, and then my second term, I have a product here, and it equals 0. So we're using that zero product rule. Okay, let's solve. So we're going to do subtract 3 from both sides, add 3 to both sides, and you end up with this 2x is negative 3, 2x is positive 3. Okay. Now, we're going to divide both sides by 2. Oops, sorry, you guys. You don't see that. Okay. Divide both sides here by 2. And what do you guys get for x? Looks like x is negative 3 halves, and you could leave your answer that way. And x is positive 3 halves. All right, so now you're going to write this as negative 3 halves, comma, positive 3 halves. And you are what? You're done. You solve by using the zero product rule. So remember, this is a special factor strategy where you have a difference of perfect squares. Okay, so let's see what 43 looks like. I have 16x squared minus 1 is 0. Okay, so I do have my 0 here. But what's the problem again? I'm going to have to factor. What do you guys know about 16x squared? Is that a perfect square?
No.
Perfect square. What about the number 1? Is that a perfect square? Sure is. And again, I have a difference. So let's figure out what was squared. What was squared to get 16x squared? 4x. Good. And then what was squared to get 1? 1. This is my difference again. That equals 0. So my difference of perfect square formula says I need to just determine what the bases are. Base is 4x. That goes right here. 4x and 4x. The other base is what? 1. So that goes here and here. What are my signs? Plus and what? Minus. Now what I'm going to do here, I guess I'll be consistent. Use the zero product rule. First term is 4x plus 1, and that is 0. That's this term right here, 4x plus 1. The next term is 4x minus 1, and that is 0. And that's the term right here. Okay, remember, you have a product, and it equals 0. You're using that zero product rule. So now you just have to solve for x, your nice linear equation. Subtract 1. What's this one? Add 1, right? So you get 4x is negative 1. 4x is positive 1. Divide both sides by 4. Same locations. Let's write our final answer. X is negative 1/4, or x is positive 1/4. My two what? Solutions. You are done. Take a look. This is 43. You're solving a nice quadratic equation by factoring. Okay, so you're going to have to even know the special factoring formulas. So here we go. Here's 45. Is it 45 or what number are we? Not 45. Is that right? 43? 41? 43? Wow. What happened here? Okay. The numbering issue. Okay. Yeah, there's what it is. Okay, I'm going to have to fix these numbers. That's what I see. Okay. X to the third power minus 4x equals 0. Okay. I'll have to fix those numbers. So we'll do as much as we can here. Okay? All right. All right, let's ask you guys. You have 0 here. And you know you have to factor because you don't have a product and you're solving these equations. By the way, this is no longer quadratic. So what I want to say to you guys is note the following. This is not a quadratic. Does anybody know why? What's your highest power? Highest power here is a 3. Is that true? Because the highest power is 3. To be a quadratic, your highest power has to be 2. So what I want to say to you is that this technique of using the zero product rule that we've been doing, this can be used in general. And you do use it in general in every math class that you take after this course, right? Intermediate algebra, trig, pre-calculus, calculus, every math class involves this strategy, this idea. So it's why it's very important, why we cover it and and give it a lot of time. But what I'm going to say to you guys is you also learned here not just to factor like with chicken soup or what, beef stew, and your special factoring formulas. You also factored how? Completely. Is that true? So your factoring completely homework is now coming into play here. This all fits together. And so if I ask you to factor completely, how do you do that? In other words, what's your procedure when you factor completely? Don't you always first do what? First you factor out the greatest common factor of your terms. What is the greatest common factor here? Good. So there's my x. And then you factor the what? The quotient. But in order to factor the quotient, don't you have to know what the quotient actually is? The answer is yeah, we got to know the quotient. So let's find out what this quotient is. Let's do our algebra. We get x squared minus 4 for a quotient. So what you have now here is this x times x squared minus 4. That equals 0. I'm factoring completely this left side. Factor completely. It's just we're not done yet. And the reason we're not done is because what I have to do with this. Yeah, I have this to factor now. The question is, what is x squared minus 4? This is the quotient. How did I factor that quotient? Well, what was it? It was a difference of perfect squares. So your homework on difference of perfect squares here is going to be used also for solving these equations. So again, it goes back to you knowing what a perfect square is and how to factor those things. So those are the kind of things you're going to see. Now, let's talk about one thing. Anybody have any question about what we just did here? What we did is what we've been doing. Here's my GCF. Here's my quotient. Okay, right there. We just did what? We just factored it. All right. Now, what comes next is we call this the what again? The zero product rule. Does anybody see anything different with this situation? Yeah, let me let you guys notice that. Notice this. I'm not going to draw a T. You know what I'm going to do? I don't know even what that is, but it's not a T. It's a what?
Pi.
Okay, looks like pi. All I'm doing really is separating my paper. It's not even paper, but I'm separating my fake paper here, electronic paper, into 3 spaces. The T is just separating into 2 spaces. I'm separating this into 3 spaces. So here's why I'm going to do that. Let me change some colors and see if you guys notice. This is my first term. So this is a generalization here. That means x is 0. Generalization of the zero product rule. Zero product rule only gave us 2 terms. Here's my, oops. Here's my second term. Let's find out here. Second term, x plus 2. So I'm going to say that x plus 2 is 0. And then finally, maybe, I don't know. Fine, let's do this. Let's do gray. I don't know if you can see the difference. Maybe you can't. There you go. X minus 2. And let's say this now. The last term here will be x minus 2 is 0. So what's going on here is that you have a product of 3 terms and they equal 0. The only way that can happen is if at least one of those terms are 0. Either 1 or 2 or all 3. So what you're going to get now after you factor completely is going to be equations you have to know how to solve. The good news is the first equation is solved already. X is 0. I have to solve the next equation. I just either translate, right, or subtract 2 from both sides, and now I get x is negative 2. Here's my second answer. And then again, I translate, or let's just say I'm going to add 2 to both sides. Now what do I get for x? X is positive 2. So my solution set is going to be 0, negative 2, positive 2. This is factor completely here, solving an equation that's not necessarily, in this case, it's not a quadratic. So this procedure of factoring is really, really, really big. So hopefully you spend a lot of time with your factoring and factoring completely, right? Because now you can do something with it. You can actually solve these equations that are higher order. You know, it doesn't have to be a quadratic. It could be higher order, meaning highest power is 3 or 4 or 5, and we're going to see some of these. So that's what I wanted to include here today for you guys. A little bit of higher order. We'll do what we can for this higher order. We'll see how this works. This is going to be now x cubed minus 25x is 0. What's your highest power again? What's the highest power for x? Isn't that 3? Okay, so the highest power here is 3. That means it's not a quadratic. We're going to have to factor what? Factor completely. Okay? So what's your greatest common factor? Again, you're right. It's x. Could you guys tell me what the quotient is? Is it x squared minus 25? How'd you do that so fast? Anybody, you guys remember? I mean, how do you do that? Can you go through the procedure? Yeah. But by now, with enough homework questions, you might say to me, I really think I could do this without having to go through that procedure. But if you can't, I recommend doing the what? Doing that procedure again. Greatest common factor, my quotient. This I have to what? Factor. What is that? Do you guys know what that is? It's a what? Difference of perfect what? Squares. So let's factor that. X plus 5, x minus 5. What do you use now? The zero what? Product rule. And it's going to be the zero product rule now in general. So it's not a t, it's now whatever that is. X is 0. X plus 5 is 0. X minus 5 is 0. We already solved this first one for x by just letting it be 0, because the only way you can multiply 3 different terms and it equals 0 is if at least one of them is 0. So how do I solve now? X plus 5 is 0. Just subtract 5. How do you solve x minus 5 is 0? Just what? Add your 5, right? And you end up with x is negative 5 and x is what? Positive 5. What's the solution set? Yep, 0, negative 5, and 5. So there's 3 items in our solution list. Right? Solution list, solution set. 3 items. All right, you guys okay with that? 0, negative 5, positive 5. This is how we solve higher order, not necessarily quadratics. 49. Let's see if we can figure this out. We got what? This one's interesting. 5x cubed minus, I think that was a typo on this one, right? I think so. This is the one where it's 125x squared, and that's 0. Okay? So here's what we're going to do here. I think that's just x. Yeah. Okay. Again, higher order, because we notice that the power here is 3. So we're going to have to factor again completely. Right? Factor completely. What's your greatest common factor? Anybody remember? Well, for the number 5 and 125, what is it? It's 5. X to the third, x to the first. X, good. It's always x, the smallest power. Do you guys know what the quotient is, or should we do some work to find it? 5x cubed minus 125x over that greatest common factor of 5x. Let's find the quotient. Let's do some work then. 5x cubed over 5x, right? Minus 125x over 5x. X squared minus, what's that number? That's 5. Okay, so let's put this together. I got 5x times x squared minus 25. That equals 0. I have a greatest common factor, and I have a quotient. I factor the what? Quotient. That's your factor completely strategy. Okay, so there's a difference here now of perfect squares that we need to factor. And when we do, we get what? 5x times, what is 0? X plus 5 and minus 5. Here's the deal. We have what's called the general form of the zero product rule. Let's take a look again. My first term right here. Okay. My second term right here. And then maybe my what? Third term here. All multiply together to get 0. And then what that means is 5x is 0, or x plus 5 is 0, or my x minus 5 is 0. Okay? Now, how do I solve each one of these linear equations? Because you're going to see solving equations again, too, on your final. Right? What do? Divide here by 5. What about this one? Translate your 5, or subtract 5. What about this one? Translate your 5, or what? Add 5. We get x going to be, what's 0 divided by 5? X is going to be negative 5, and x is positive 5. So my solution set will be 0, negative 5, and positive 5. My 3 answers. This is the procedure here for solving a higher order. This is not quadratic. Quadratics have the highest power for your variable to be 2. It's a higher order equation, but it's the same technique. You just have to factor completely. And you know that because you've already done it. Okay. All right, so let's see this next one here. We've been factoring completely. Okay, this is kind of interesting. X to the 4th minus 49x squared is 0. Okay. All right, let's take a look at this one here. Notice again, is this a quadratic or is it higher order? How do you know? Highest power is what? 4. Okay, good. I guess we have to factor completely. All right. What's your GCF? GCF is x to the 4th, x to the 2nd. It's always x to the smallest what? Power. Okay, what's the quotient going to be? Can you guys tell me what the quotient is? Can you tell me what it is without doing all the work?
X squared minus 49.
Good job. X squared minus 49. Okay. I write this as greatest common factor times a quotient, and that equals 0. Let's emphasize. GCF quotient. What am I supposed to do with this quotient? Right, we're going to factor our quotient. We have a difference, and we have what? Perfect squares. Difference of perfect squares. Now, let's go through the factoring of the difference of perfect squares. I already have x squared there. Then I have x squared minus 49, and that equals 0. Difference of perfect squares, I have x squared, x plus 7, x minus 7. This is your difference of perfect square formula. Okay, so now again, we're going to bring out this table. Let me emphasize this here. Okay, it's not that big a deal. Let's take a look. My first term, oops, let's go back. Okay, my first term, and then I have a what? Second term, and then I have a what? Third term. So I'm going to set all these terms, x squared equal to 0, x plus 7 equal to 0, and x minus 7, oops, equal to 0 as well, x minus 7. How do we solve these for x? Let me try to do the second one here. Subtract your 7 from both sides. Is that right? Add your 7 or translate. So for these last two, x is going to be -7, and x is going to be what here? Positive what? 7. All right, you guys okay with that? Now, what about this first one? X squared is 0. What's the only thing that x could be if x squared is 0? Right? Isn't x squared x times x, and that is 0? What does that mean about x? The only way that can happen is if either the first x was 0 or the second x was 0. Is that true? In other words, what's my solution set? 0. What else? -7. What else? What's another solution for this? +7. You are what? Done. You solved a higher order equation by using the tools of factor completely and the zero product rule. So that's what we're going to do here. Okay, 51. Okay, pretty interesting. 53. Okay. You have what? X to the 4th minus 36x squared is 0. So you already know, let's go through this. Highest power is 4. That's not a quadratic. It's a higher order equation. So if this is higher order, again, remember we have to factor here. Okay. Greatest common factor. X squared. What's the quotient going to be? Good. How'd you do that so fast? Practice. Good answer. Perfect answer. Practice, practice what? Practice. See, this is where all the time and energy we put into this factoring and factor completely, learning about perfect squares, perfect cubes, it's going to pay off because you're even going to see it, not just on this final, you see it in the future for intermediate algebra and all these other math classes. These are the fundamentals. So when I put this all together, I got my greatest common factor. I got my quotient. Okay. DCF. Q. What do I notice about this quotient? It's a difference again of perfect squares. So let's factor. X plus 6, x minus 6. Again, I get the 3 terms. I get my x squared. Boy, I really did that today. Get my x squared. Get my x plus 6. Get my x minus 6. All 3 of those terms get set equal to 0. X squared is 0. X plus 6 is 0. And x minus 6 is 0. We can solve this for x now. Here we go. Subtract 6. Add 6. Here we go. X is 0. X is negative 6. And x is positive 6. Here's my solutions. 0, negative 6, positive 6. Same exact format like you did in the prior problem. Okay, same exact format here. So let's see how this next problem is different here. You got x cubed plus 5x squared plus 6x. Is that value 0? So is this higher order? Absolutely. Highest power is 3. Higher order. So here's the deal. Greatest common factor is x cubed, x squared, and x. What's your GCF? X. Good. Could you get me the quotient? Good. Isn't that just actually writing this down as what? 1 degree less for the power? because you're dividing by x to the first power. Okay, so we get x times x squared plus 5x plus 6 is 0. Greatest common factor. Quotient, you have to factor that quotient. And again, you get x, and then we have to think. This time, there is not what? We don't have the difference of perfect squares. What recipe do we use? Chicken soup or beef stew? I think we use what? Chicken soup. Good job. Okay, good. I bet you all those recipes, what? You got to remember? Okay, chicken soup. How do we know this is chicken soup? It's x squared plus bx plus c. Okay. How many terms here? Then we have what? The x term, that's first term. Second term, x plus 2. And then you have the last term, x plus 3. So we got all the terms here. X equals 0. X plus 2 equals 0. X plus 3 equals 0. So we solve each one of these for x. Subtract 2, subtract 3. The first one is already solved for x. X is 0 here. Now we get x will be negative 2 here, and x will be negative 3 here, and here we go. Final answer is 0, negative 2, negative 3. You are what? Done. Okay, so this is what you can see here for, again, you know, your factoring technique here. This is a higher order equation. Whew. All right, let's see. Let's try another one. This is number what? 55. So this would be 57. If we number this the way it should be, it'll be x to the 4th plus 12x cubed plus 35x squared is 0. All right. Again, we're going to notice that this situation is considered a higher order equation. Now, again, you guys are okay with this because of the fact that if you know how to factor completely, which was your homework, you know, then we could do that. So let's get this. Greatest common factor. What do we get? Isn't this x to the 4th, x cubed, x squared? What's your GCF? Good job. So can we find that quotient? Oh my gosh, you guys are pretty good with that. All that practice. That's what happens when you do all the practice. So we get x squared times x squared plus 12x plus 35, and that equals 0. And again here, greatest common factor and your quotient. You got to factor the quotient. And again, you use your chicken soup recipe. X plus 7, x plus 5. Good. 0 product rule. Now I have 3 terms. So 3 terms. First term. Second term. And again here, my third term. So I'm going to say here, x squared is 0. X plus 7 is 0. X plus 5 is at 0. Subtract 7 from both sides and subtract 5 from both sides. You're going to finally get, this is x is 0. X is negative 7. X is negative 5. Okay, we solve this higher order equation. All right, let's see what we have here. How about this? This is number what? 59, I guess. Okay. See what we can, see where we end with this. All this practice. Where are we at here? I think we're here. X to the third. Well, how about if we try this here? Let's do this here. Since we're going to renumber them, how about we go down here? Let's try this here. Let's try that. 2x cubed minus 22x squared plus 60x. This equals 0. Let's try doing that. Yeah. Okay. Okay, do you guys notice, is this higher order? That's higher order, is that true? Okay. So, I need to factor completely. Greatest common factor is for x cubed, x squared, and x. Oh, good job, you guys are awake. 2, 22, and 60, 2x. Can you guys tell me what that quotient's going to be then? Everybody know? You said no, we're all asleep, so maybe we should do some work. All right, let's try to do some work, I guess. 2x here. You get what? 2x cubed over 2x minus 22 what? X squared over 2x plus 60x over 2x. So I'm going to have, sure enough, x squared minus 11x, that's 11, and then 60 divided by 2 is what? Plus 30, and my x's cancel. Here's my quotient. So 2x times x squared minus 11x plus my what? 30. Oops. That's 0. I don't know what happened. Okay. GCF. My quotient. What do we do with that quotient? You what? Factor your quotient. Okay. 2x. What recipe is this? Chicken soup or beef stew? Okay. X and x. What's the numbers? 5 and 6, but what are the signs? Are they both negative?
Yes.
Okay, good. 0 product rule. Again, we have our first term, second term, last term. So each one is equal to 0 here. Each one's equal to 0. Because my product here, let's actually really talk about it, times 0, the 0 product rule. All right, here we go. Let's solve this for x. Divide both sides by 2. Add 5. Add 6. Translate. Translate. 2's go away. You're left with x equals 0, x equals positive 5, x is positive 6. As a solution set, as a list of solutions for x, your answers are what? 0, 5, and what? And 6. Okay?